In this lesson, we will be studying linear equations and their intercepts. We will be verifying that solutions are in fact solutions to a linear equation, or perhaps they are not. We will graph using a table of values. We will write equations in slope-intercept form, and we will find intercepts algebraically and visually. Let's go to our first objective. We will verify some solutions. We have a couple of points, and we want to verify if these points are solutions to the linear equations. Well, here's our one linear equation, so let's verify if it's a solution. The way to verify, if you're not already thinking of this in your head, remember that each of these points represents an x value and a y value. And within our equation, we do have an x and a y. So all we need to do is substitute these values in and see if it works. So we'll go ahead and put in a 1 for x, and then we will put our 2 in here for y. And we will compare the left side of the equation to the right side. So we've got our 1 plus 3 times 2 is 6. And then let's sum this together. 6 plus 1 is 7. How does that compare to 6? Does 7 equal 6? Right now you should be saying no, that does not equal 6. So this first point, this is not a solution. So I'll put an X by it, not a solution. Now let's look at the second point. We'll do the same thing with the second point. So we've got an X and we've got a Y. We'll plug in the -3 for X. We've got 3 times 3, plugging in that 3 from here, and we'll compare that to 6. So simplifying the left side, 3 times 3 gives us 9. -3 plus 9 means we subtract because we have one negative in there, so we get 6 equals 6. How does that compare? Does 6 equal 6? It does. So B here, that is a solution to this linear equation. Let's look at what this looks like graphically. So remember, we had the point 1, 2, and then -3, 3. If we want to graph this equation, this is the same equation we just got finished looking at. It's difficult to graph like this, so let's switch it to y equals mx plus b form, slope-intercept form up here. And we do that by isolating y, solving for y. So we'll subtract x from both sides, and we will get x minus x is 0. And then on this side, you can't subtract those are not like terms, so we need to write them both. And then we would need to divide every term by 3. So 3 divided by 3 is 1. So we would have y equals, and this is negative, remember there's a 1 in front of the x, so we can write this as -1/3 x plus 6 divided by 3 gives us 2. Now let's graph our equation. Our y-intercept, remember, is what we graph first right here, this 2. Okay, this 2 is our y-intercept, so always start there. That's our starting point. And then we look to our slope to help us find the next point. It's negative, so our line has to angle down from left to right. Keep that in mind. So if I go up 1, I need to go to the left 1, 2, 3. Okay, and 2 points is plenty. That's all we need to make a line. And we'll draw a line there. And I'll just keep going all the way through. Maybe I'll straighten up my line a little bit. I want to be a little bit more precise. Okay, so let's go back and look at what we said. So back here, we said 1, 2 was not a solution. Let's go ahead and find 1, 2 on this. Here's 1. If we go over 1, we'll do that in red. And if we go up 2, it's close, so close. But you can see that 1, 2 is definitely not on the line. So we can see that graphically. And then we proved it back here algebraically when we plugged in 1 and 2 into x and y. Now let's look at our second point. We had -3, 3. So -3, oh look at that, 1, 2, 3. In fact, that's one of our points that we graphed from our slope. So -3, 3 is definitely on the line, and that's what we said. So let's look at part 2 here. It says locate the X and Y-intercepts and write as a coordinate pair. We will be looking at those today, so let's look at them on this line. Our X-intercept is right here. It's not on an exact value, but we'll just estimate it. If this is 4, it looks like this one is 5, so it's about in the middle. So I would write this as 4.5, 0. Our Y-intercept is right here. We already located it in our equation when we wrote it in slope-intercept form. We would write that as 0, 2. One thing I want you to notice is that our X-intercept will always have a 0 here for Y, and our Y-intercept will always have a 0 here for X. Okay, that'll make it easy for us to find that algebraically as we move on. Now let's write these equations in slope-intercept form, and that's what I did in the prior example to help us graph it. So let's do a little practice with that, review that some. Got 2 equations here. When we do that, we know we want it in the form of y equals mx plus b, right? That is our slope-intercept form. So we have to solve both of these for y. And in order to do that, I will need to move the 3x to the other side on this one. Move that to the other side. And then let's write what we have. 3 minus 3, that's gone. And we're left with 4y equals, we can't combine these, right? We can't combine 12 with negative 3x. Those are not like terms. So we would be left with negative 3x plus 12. And then we need to divide by 4 to isolate the y. So we would need to divide every term here by 4 as well. 4 divided by 4 is just 1, or 1y. And that equals negative 3/4 x plus 12 divided by 4 is 3. Number 2. Let's go ahead and move over the 2x by adding 2x, since there's a negative here. And then let's write what we have. Negative 2 and a positive 2 cancel, turn into 0. We're left with negative 4y equals 2x plus 9. Again, can't combine these terms, they're not like terms. We will divide by a negative 4 in order to isolate our y. Make sure you divide every term then by a negative 4. Negative 4 divided by negative 4 is just 1, or 1y. Now 2 over negative 4 can reduce. 2 goes into both negative 4 and itself. 2 goes into itself 1 time. Goes into negative 4 and negative 2 times. Okay, and then our final answer, we have 9 divided by negative 4 leaves us with negative 9/4. It's not a pretty answer, but we could graph it if we needed to. Now let's do a graph using a table of values of at least 3 points. Okay, in this first example, we can look at it and say, well, I don't need to graph it because I can look at it and graph it using the y-intercept and the slope, and that's great. But what we're going to do is we're going to practice making a table of values and graphing it that way so that you have multiple options for graphing. So usually what I like to do is I like to start with a negative number. So if we're only going to do 3 points, I'll go ahead and start with a negative 1. I'll choose 0 and 1, so they're all in order. And I choose 0 specifically here because if you remember back when we were looking at intercepts, when x is 0, in this case y was 2, that's our y-intercept. So if I choose 0 for my tables, I can determine what my y-intercept is and graph it more easily. All right, so in the first example, I would plug in a negative 1 for x. So I would have 3 times negative 1 minus 2. 3 times negative 1 is negative 3 minus 2. Well, a negative 3 minus 2, I can change that to a plus as long as I put a negative on there. I'm adding 2 negatives, so I get a negative 5. And that's what my first answer is. If I plug in a 0, well, 3 times 0 is 0. So all I'm left with on this side is a negative 2, but you already knew that because this is our y-intercept. Now let's do a 1. So let's plug in a positive 1. And we get 3 times 1 is 3, and 3 minus 2 is 1. Now if we want to graph these, I have 3 points. It's more than enough points to graph a straight line. So I go -1, -5, and that's my first point. 0, -2 is my second, and 1, 1 is my third. And again, this is more than enough points to graph a straight line. If I did not have a straight line, then I would need more than 2 points. But since we know we're graphing linear lines, that's all I need. All right, let's look at our second example, going from a table. All right, in this example, let's make sure we label our x here and our y's here. So again, I'm going to try the -1, 0, 1. It seemed to work well on the last one. I plug in a -1 here, I would get 2 times -1 plus y equals 5. Okay, I'm actually going to rewrite that because we're going to need a little more room to do a little more math. So let's adjust this. Okay, so it works better here. It gives us a little more room. So I just moved everything over a little bit, and I'm plugging in my -1 now. And I'm going to solve for y. So 2 times -1 is going to give me -2. I need to move the 2 over, so I would add it to both sides. And I would be left with 5 equals 5 plus 2 is 7. So my first number is going to be 7. Okay, so when x equals 1, I know then that y equals 7. And we'll move that up a little bit. So for my second one, I've got a 0. So again, that'll be easy. If I plug in a 0 for x, 2 times 0 is 0, which just leaves y equals 5. Very nice. Now I know my y-intercept. Let's look at 1 then. So if I plug in a 1 in for x, I get 2 times 1 plus y equals 5. 2 times 1 is just 2. And so I'm going to go ahead and subtract 2 to move it to the other side. And I would get y equals 3. Okay, great. Now I'm going to plot the points here. I've got -1, 7, 0, 5. That's my y-intercept. And 1, 3 right there. More than enough points for my line. And there it is. And that's a review of how to graph using a table of values. What's nice about this is it doesn't matter how you write the equation, you can still plug numbers in and solve eventually. Now I want to show you these so that you can see how these are. We've looked at some of these before, but they always continue to confuse people. So let's look at our first situation where y equals -2. So I'm going to pick a -1, I'm going to pick a 0, and I'm going to pick a 1. There's no x value here, right? There's nowhere to plug that in. So no matter what, y is always going to be -2. So how does that look on a graph? Well, if I go -1, -2, that's right here. If I do 0, -2, that's right there. And if I do 1, -2, that's right there. You can get an idea already what this is going to look like, right? This is going to be a horizontal line. So this is a horizontal line. So anytime you have y equals, you have a horizontal line. And if we look and think what our slope is going to be 0. Okay. There is no change between y values. Going from -2 to -2 has a change of 0 and has a change of 0. So our slope is 0. All right, let's look at our second example. Now we have an x equals. So again, if I make my table of values and I plug in a -1 here for x, what happens? -1 equals 3, that does not work, right? How about 0? 0 equals 3, that doesn't work either. And how about 1 equals 3? None of those work, right? So this is not actually a linear function. If I plot this, if I go to where x equals 3, that's right here, and I draw a line through it, this is a vertical line. Okay, so anytime you have an x equals, you know you're going to have a vertical line. So for any value of for any value of y, x will always be 3. So I can't plug in -1, 0, 1, but what I can plug in is a -1 here. I could plug in a 0 and a 1, and x will always be 3, 3, 3. And this is what I've drawn. So at 3, I have a point here at -1. Also at 3, I have a point at 3, 0, and I have a point at 3, 1. This is a vertical line. But in this case, this is not a function. Okay, this is not a function. A vertical line is not a function. And the slope, in this case, is undefined. And I'll show you that. Slope is undefined. Okay, and write that in your notes. And here's why. If we look at the change in y, we do have a change in y, right? We have a change of, +1 each time, and that was because I chose those values, right? We have a change of +1, and another change here of +1. But what happens here? We have a change of 0, we have a change of 0. Can you have division by 0? And the answer is no. And the reason we have division by 0 is if you think about slope, right? Slope is just rise over run. Our rise in all these cases would be 1. But what's our run? Our run is 0. And so this is why it's undefined. Okay? We cannot divide by 0. So this is not a function and the slope is not defined. Okay? And if we go back over here, let's write in here, we already did, slope is equal to 0. Now let's look at finding the x and y-intercepts based on what we talked about. So in this case, remember that your x-intercept has a y value of 0. So the x-intercept, y value equals 0. And for our y-intercept, the x value equals 0. Okay, and you can picture that if we come back to this other problem. Here was our x-intercept, and look, our y value is 0. Here's our y-intercept, and our x value is 0. So it's pretty easy to find. All it means is that we are going to plug some things in. So let's find our x-intercept first. And we just said that the y value was 0 there, right? Well, if I plug in a 0 for y here, so I end up with, let's go ahead and do that, x plus 3 times 0 equals 6. Well, 3 times 0 is just 0, so our x value would be 6. Now, always when you do your intercepts, you don't want to just say x is 6. You actually want to fill it in. So our x-intercept is 6, 0, right? It's a location, so we need both an x and a y. All right, now let's do our y-intercept. So for our y-intercept, in order to do that, we know that x has to be 0. So let's go ahead and plug in a 0 for x plus 3y equals 6. Divide both sides by 3, and we would get 3 divided by 3 turns into 1. So our y-intercept is going to be at 2. And again, make sure we write that as an ordered pair. The y-intercept is 0, 2. And a lot of people have trouble with writing these, so if you write this first, 0, y, it gives you a format to follow. Make sure that you put the 0 in the right place. Okay, let's do the next one. In this case, let's do our x-intercept first. So we're going to be finding x, so we know we're going to plug in a 0 for y. And going ahead and solving, we have 6x minus 9 times 0 equals 18. Well, 9 times 0 is 0, so 6x equals 18. We need to divide both sides by 6. 6 divided by 6 is 1 or 1x, and 18 divided by 6 is 3. That means then that our x-intercept is 3, 0. All right, let's do our y-intercept. Let's move this over just a tad. All right, to find our y-intercept, we're going to be plugging in a 0 for x. So let's do that. We're going to plug in a 0 for x, and we're going to solve for y. So we would end up with 6 times 0 minus 9y equals 18. 6 times 0 is 0, so we have negative 9y left on that side, equals 18. We need to divide both sides by negative 9. Negative 9 divided by negative 9 is just 1, or 1y, and 18 divided by negative 9 is negative 2. So our coordinate pair here is going to be 0, negative 2. Okay, and that is how we find the x and y-intercept algebraically. We could graph these and connect those, and then we would have our line as well. All right, here is our final problem. We have a contextual problem, and here is the scenario. The average lifespan of an American woman is modeled by this equation, y equals 0.2x plus 73, where when x is 0 is 1960. So 1960 is representative of 0, is what that's saying. The question is, what is the y-intercept and what does it mean? So let's go ahead and put some things on this graph so we can understand this equation better. Well, first of all, the y-intercept we know is always here at the end, right? This 73. So 73 is going to be our y-intercept. Now let's do a rough sketch of our graph. Well, a slope of 0.2 is going to be very gentle, right? That's 0.2 over 1. Or if we move the 0 or the decimal point out, we multiply both by 10, we would get 2 over 10. So up 2 over 10, that's a very gentle slope. So our line is going to look like that. So our lifespan is going to be increasing so slightly over time. Put some labels on our graph. Well, since x equals 0 is 1960, we know that our x-axis is going to be time. And our y-axis right here, this y represents, it says, the average lifespan. So y is going to represent average lifespan. So I'll just write lifespan up here. Okay, so the question is, what is the y-intercept and what does it mean? Well, the y-intercept, let's go ahead and do the coordinates for that. Y-intercept is going to be 0, 73. And the equation said that when x is 0, that means it's 1960. So what that means then is that at 1960, because that's what 0 is, the average lifespan of a woman was 73 years. Okay, so we can write that as in 1960, the average lifespan of a woman, okay, so of a woman was, because it's no longer 1960, 73 years. Okay, so we could continue on up. We could find another point up here, maybe in here somewhere. Maybe this would be 20 years later, so maybe that's 1980, and we could go up here and see where it hits the graph and figure out what the lifespan is of a woman in 1980. And if you continue and follow the trend, okay, a woman's lifespan is increasing very slowly per year, only 0.2 per year. All right, and that concludes our lesson for today.